Hey everyone, welcome to Classic Mini DIY. On today's episode, I am going to be covering the entire swap from a carburetor over to a fuel-injected throttle body and everything that entails. So, stay tuned for that. All right, hey everybody, welcome to the next episode of Classic Mini DIY. Now, as you can see here, there is a lot going on in this engine bay, and I'm gonna cover everything that's happening and how we got here, what we came from, all of those different things. Now, I initially started this video with a little bit different plans, and it was about halfway through that I realized that doing wiring and doing plumbing and all of these different things that I'm gonna show you guys on this car is really hard to film. It is extremely hard to film. So kudos to people who write complete DIY guides on wiring because it is a task. Now, the reason I think that is because when you start off on a project like this, you have a certain set of plans, and throughout the project and throughout the implementation, you often find things that need to be a little bit different than the setup you initially anticipated. So as a result, what I wanted to show you guys when I was filming these little clips that you're probably seeing on the corner right now is considerably different than what I want to talk about today. So as a result, we're going to take a different approach to this, and I am going to show you guys everything that this fuel injected setup needs, how we got here, what I did in order to get us there, and I'm going to leave it to you guys to ask any questions that you might have. Now, in the future, I am going to be doing a video on the quick and easy way to swap your car to fuel injection. And spoiler alert, there is not really an easy way to swap to fuel injection, but there's a way to do it in which that it's not super difficult and that it's at least straightforward. Now, before we get into the nitty-gritty of how all of this goes together, I want to mention, if you guys have not seen, we are now carrying a fuel-injected throttle body, billet aluminum, fully custom, that bolts right onto an HIF 44 intake manifold. That is now available for sale, and we are shipping those out as quickly as we possibly can. Thank you so much to everybody who pre-ordered. You guys got in at that early bird special, but I'm really excited to share with you guys that we are able to keep the price of that throttle body quite low. It's much lower than the others on the market, and I think you guys are gonna be really pleased with the quality and the setup of this unit. And I'm gonna show you guys how it all goes together when we get to that part of this episode. With that little short ad out of the way, let's get into the engine itself and how it all goes together. Now, to start off, let's talk about the way that this engine works and how everything is kind of working in unison, but how the A-series engine is a little bit different than most engines you might work on. Now, for my setup, we have a turbocharger. This turbo sits way off to the side here, and all of the air goes into the turbocharger. Boost gets generated, driven through the actual intercooler that's on the front of the car here, and then up and into the throttle body at the top. That throttle body has two injectors on it, and those two injectors fire fuel into the throat of the throttle body based on a whole bunch of different factors and how much fuel it needs. And then that gets separated into two ports, and then those two ports get separated again to your two cylinders. Now, this introduces kind of an interesting issue, and it is something called Siamese port robbing. Now, you don't run into a lot of this pain when you're using a carburetor because the carburetor effectively is just constantly pouring fuel into your engine, and you have something that's called a wet manifold. On a fuel-injected setup, this is a little bit different in that your injectors normally on modern cars would have a set amount of fuel that they deliver at a certain interval, and that gets delivered directly into those cylinders. Now, long story short, what happens with the Mini is that as you're pulsing that fuel through those fuel injectors, if it's not done correctly, that fuel is pulled into the wrong cylinder and you end up having weird leaning out issues. The car doesn't run very well. And if I had a nickel for every time somebody told me that this isn't going to work because of Siamese port robbing, I would be able to pay for the entire fuel injected setup. Now, I want to stress the fact that it does work, and it's all about getting the right settings. Really bolting on the throttle body and hoping it will work is not really how fuel injection works. The concept of fuel injection requires sensors, data, and the correct configuration. And when you get all of those correct, you end up with a really nice running engine, even when you have these special caveats that come with the Classic Mini. Now, we will cover more of this in the tuning episode, but I do want to mention it in short. What we're doing is we are going to be mimicking the way a carburetor works with this fuel-injected throttle body by setting it to something in the Haltech ECU to multi-point injection. And what that means is both of your injectors are firing twice per engine cycle, and they are running 180 degrees out. So the goal is that these injectors are getting that fuel twice and keeping the inlet manifold wet so there is a constant flow of fuel into your engine. The drawback of this is that you do use a little bit more fuel, but it's comparable and likely still a little bit better than the carbureted setup that was originally on the car. So if you want to know more about that, there are some articles that I can send you guys. I'll post those in the description below. But long story short, there are ways around this. Lots of people fuel inject Classic Minis. There are entire businesses built off of fuel injecting Classic Minis. So, you know, if there was actually an issue that was preventing this from working, we would not be here today. So with that said, let's jump into the hardware setup that we have on the car here. Now, as I was mentioning, that air goes through your inlet, throttle body, gets fuel, engine runs. But there's so much that comes along with that. Now, first up, let's talk about the fuel system. This is a fuel-injected fuel system, which means you need a feed and a return line, and you'll need a fuel pressure regulator that can handle the higher pressures required by EFI, and you'll need to make sure that all of your lines throughout your system can handle that higher pressure as well. The easiest way to achieve this is by simply putting in a SPI or MPI fuel tank in your Classic Mini. This uses a more modern style fuel pump that comes in through the top, and the top has a feed and a return on it, so you can actually just plumb this up like you would any other modern fuel injected car. And then that pump inside the actual fuel tank needs to be likely around 180 liters per hour. I have a 240 in mine due to the turbocharged setup, but if you're running a naturally aspirated car, the 180 should be enough flow for your setup. Your mileage may vary a little bit depending on the configuration that you have. And then after you have both of those lines set up, you'll have both of those running to the front of your car, to your engine bay. And there are two effective ways that you can run a fuel rail on a Classic Mini. The fuel rail in our case is what is mounted to the throttle body and holds the injectors in place. You can run what's called a deadhead fuel rail, or you can run sort of a pass-through fuel rail, which is what I've done. The feed will come in the right side of the fuel rail. That is the feed coming from your fuel tank, and then that will run into the fuel pressure regulator. And then the fuel pressure regulator will be used to set the pressure to your base fuel pressure, which in my case is about 45 PSI. And then the return will run down and to the return line going back to the fuel tank. So you have one effective continuous circuit. Now you'll notice that there is an additional line running to that fuel pressure regulator. That is required for a boost reference. In my setup, I require the fuel pressure to increase 1-to-1 with boost pressure. And so as the increase in boost happens, I need a linear increase in the amount of pressure being delivered to those fuel injectors so that my engine continues to run properly when it's under boost. Depending on your setup, you may or may not need this, but it is something to consider when you are checking out and picking out your fuel pressure regulator. Now, with that, I do want to mention that everything that you guys are seeing in this episode is going to be posted in the description below, all the links to the different items that I used. And if you have any questions about those, these are options for you if you are going to run this setup, but are not necessarily the ones that you have to choose. Now the next thing that we're looking at is the piping going into the engine. And this is a pretty quick topic, but it is something that is worth mentioning. With my setup, I wanted to run something called an intake air temperature sensor. And that does pretty much exactly what it sounds like. It measures the temperature of the air going into your engine, and that is going to be running to my Haltech ECU to help inform the fuel mixture that I'm going to be running on my car. This is not a required sensor for all cars. This is not a required sensor for most EFI setups, but it is one that is going to help provide you more data and a better running car. So it's something that you can consider adding if you'd like to. The adapter plate that you see here is purchased from Specialist Components. They produce this and a sensor gets placed directly into this adapter. It's a nice little setup. Now, in addition to that sensor, you will need to add a coolant temperature sensor. This is something that can be added either in the factory location. You can use the factory sensor if you have an electric sensor already. There are lots of options for coolant temperature sensors. In my case, I'm using a mechanical gauge on my dash, and I wanted to preserve that, so I ended up tapping the thermostat housing and using that as my EFI takeoff for coolant temperature. Now the next thing that we're adding here is something that is probably going to be the most difficult to add when you are converting your setup, and that is a crank position sensor. Now, this requires you to mount a set of teeth to your engine pulley, and this pulley then will have a crank position sensor that reads a missing tooth on that setup. This is then calibrated in your ECU, and it's what tells the ECU where your engine is in its revolution. Now there are a lot of really great bolt-on setups for this, and I think the best one on the market right now is made by MED Engineering. This is a full pulley swap. It's a brand new pulley that's fully balanced, and it has the teeth integrated into that pulley. And then if you opt into getting their timing cover, it will have mounting positions for the crank position sensor, and it simply just makes everything so much easier. I cannot recommend that enough. I had to modify mine a little bit, which I would show you, but unfortunately with the intercooler and everything, it's very difficult to show you guys. But the intercooler required me to modify their original setup. If you are not running a big old intercooler like I am, then that will bolt on easy peasy as long as you can get access to that pulley and replace that. As you can imagine, since the ECU is going to be replacing the need for a distributor, you are going to need to add a new ignition system. And now originally I had an ignition coil from MED Engineering that I bought with my DTA Fast ECU. That was the ignition only ECU. Now, unfortunately, when setting up my new Haltech ECU, I put some incorrect values in for the electrical signals going to this, and I fried the 1 and 4 ignition circuit on this. But I decided to opt for a different ignition coil, one that is a little bit easier for me to access here in the US and a little bit wider used across the world. It is a VW Golf ignition coil. This is a much easier coil to work with because it has a built-in igniter, which means that you only need to run ignition signals to this coil instead of having to run an igniter in between it and setting up a whole bunch of additional settings. Just makes life a lot easier, and it works just as well. So with that, there's only one other sensor that is being attached to the car that you will also need to consider, and that is an AFR sensor. And that is an air-fuel ratio sensor. This is going to provide a lambda reading to your ECU, and it's going to tell the engine what the mixture currently is as it's running. And if you have an ECU that has a smarter system, like a closed loop system, it'll help you do some of the self-tuning setups. And it's definitely something that you need in order to get the car running properly. An EFI setup is not one like a carb where you can get it tuned really well without an AFR. It's something that I would argue is pretty much a requirement. Now, there are a few different ways you can do this. You can get an AFR setup from, Haltech. You can get one from all sorts of different suppliers. But what I have found I like the most is my AEM X Series gauge. It's super cool because you get a manual readout inside the cabin of the car on the gauge. But the gauge has a low voltage output, which is what most ECUs require and need in order to read a lambda reading. You can't go straight from the sensor directly into the ECU in most setups. And so the gauge itself is processing the AFR sensor reading, it's displaying it on the gauge, but then you're also being sent out an output signal that you can plumb into your ECU, and it makes the setup considerably easier. Most ECUs have a sensor scaling setup for that AFR gauge, and it just makes life a lot easier. So if you're looking for something that's going to be easy to set up, that's going to be the one to pick, in my opinion. Although there are other options out there if you don't really care about having a gauge inside your cabin. Now this is the part where things might change a little bit depending on whichever ECU you choose. In my case, I opted for a slightly more expensive than other ones Haltech ECU. That is an Elite 750 ECU, and that's effectively their base model ECU. And wow, man, I've said ECU quite a few times. They have other options that have more features in them, like knock detection and additional sensors, outputs, all sorts of different things. The 750 met my needs. I could have justified adding a 1500, and I might opt to upgrade to that in a future episode or in the future. But for right now, this is good. And the 750 does everything I need it to do, mostly because I'm also pairing it with a power distribution module called a PD16. Now I did a video talking about how to set up and pin that wiring harness, which I'll link in the corner here, but I'm using that power distribution module to completely power my entire car. So every circuit in the car is being run through the PD16, and it is no longer requiring a fuse box. The PD16 replaces that. So there is a large amount of complexity that is being introduced with that PD16, which I don't want to cover too in detail because I think it gets a little too specific to my car, but it is definitely not something required in order to get this set up and running. You can simply choose an ECU that works best for you and wire your sensors directly into that, and then get your fuel and your ignition map set up in a way that you like. Now, as we mentioned, the ignition map, this is something that is very confusing for a lot of people. But what I've done is I have made the ignition map for my engine public. So if you guys want to use that as a reference point, you can do that on your setups. You'll just have to translate that into a different ECU if you aren't using the Haltech ECU. But something to keep in mind is that that is not plug and play, and it is not going to get you 100% of the way there. You do need to bring it to a dyno to get it working properly. Also, it has my specific offset for the crank position sensor. So if you have your crank pulley as such here, and my sensor lives right about here, but your sensor might live down here, or it might live up here, and that is what's called the crank position offset. And in my case, it's 22 degrees, but yours, depending on where your sensor is, will need to be set. And that's done with a timing light and pretty much the exact same way you set the timing on a carbureted and distributor-based system. But I would encourage you to go look at some videos on that. Haltech has some awesome ones about how to set that, and they're going to explain it a little bit better than I can. Now, there is only one other thing I want to mention, and it's kind of an optional thing that you can add to your setup depending on the ECU you have, but I'm adding something called an idle air control valve. The one I got is actually off of a Supra. It's a Ford idle air control valve, and this lives after the throttle butterfly, and it's something the ECU controls so that when you start up your car for the first time and when it's cold, or you're just sitting there idling and you want the car to run really nice, the idle air control valve has the ability to control additional airflow into your engine past the idle set screw that we have on our throttle body. And so effectively it provides you the ability to set the idle dynamically based on the coolant, based on the air temperature, the volumetric flow, all of these different things, and that comes with the ECU. Now, again, this is not something that is required. It is something that I wanted to add. Steve, who owns the Turbo MPI, Turbo Cooper Sport on Instagram, planted that idea, that seed of that idea in my head, and so I opted to go ahead and grab one for my setup too. Now with all of that out of the way, let's start up the engine here, and I'm gonna let you guys see how it sounds, see how it works, and give you a few peeks inside the cabin too, so you can see some of the neat stuff I added. Now, because I have so much new information coming from the ECU and I no longer need a manual choke on my car, I opted to use that hole on the dash here for a check engine light. This is wired to the ECU and I have it configured to turn on if there is a fault. And so what'll happen when you start up your car for the first time, or at least when you turn the ignition on for the first time, you will get that light turning on as it does its initial pre-check, and then if there are no faults, it turns off. And it allows you to have a visual indicator if you have any faults or issues on your car. Now, some people will add a big digital dash on their car with all sorts of additional information, which, could get added at the future. But for right now, I'm going to keep it as classic looking as possible without adding a whole bunch of additional, values there. Now this is an example of what a tuning setup might look like for you guys. You can see the engine is running right now, which is indicated by this little crosshair hopping around based on the RPM and the map sensor. Now we've got it to about 80% of the output of those fuel injectors to run at this idle. And you can see we're targeting about 12.8 on the Lambda, and it's doing an all right job of keeping it pretty close there. This idle base out value is what's used to determine your idle air control valve. You guys might not have that on your car. And then you can see up at the top your fuel load, your coolant temperature sensor, battery voltage, ignition angle, all sorts of very interesting stuff here. But this ignition angle is actually what your advance is on your car. So it's tied directly to the ignition map. So you can see that right here. And we're in about 15 degrees before top dead center, but that'll obviously go up depending on the RPM and your ignition load, as I mentioned before. So I'm gonna cut the engine off, and then I'm gonna show you guys a little bit more about how this software looks and feels and works. Now, this is probably where it feels a little overwhelming if you've never done something like this before, and I totally understand that. But the Haltech setup is one that makes it relatively easy to get this all configured. However, things like Speeduino are also a really good option to use. In our case here, the way that I would recommend starting off is just working through each individual sensor and each individual valve, everything that you need to connect up one by one. And then once you get each thing done, you can compress the menu item on the left side until you've got everything configured. And as I mentioned, this is going to be available publicly, this map file. So as I start to get my fueling set up and as I might change my ignition, those are going to be all available to you guys for free. Now, obviously, I will accept, any sort of support that you guys might want to throw my way, because this took a lot of time and effort to get set up. And it'll cost quite a bit of money to get the mapping of the fuel set up. But I want you guys to have access to this because this is something that's important to me. I want all of this to be relatively democratized in the Mini world. A couple of examples you'll see here. In my setup, I have my trigger system set up, and I have 36 teeth on my crank with one missing tooth, and I have a top dead center angle of about 22 degrees offset. And this is just simply the initial configuration that'll help you get it set up. But if you have a different sensor type, in my case I have a Hall effect sensor, which is a digital sensor. You might have something called a reluctor sensor, which is using a magnet coiled around. Long story short, there are just different types of sensors. Now moving through this, we have our fuel system. This is where I was configuring the setup called multi-point that I mentioned before, where we're firing all the injectors twice per cycle, and we've got 2 injectors. And then you have your wiring associated with it. This is one of the reasons I really like the Haltech setup. It's because these these wiring configurations are super easy to configure. These are pre-configured, in this engine configuration. but things like the power for the coil, all of these correspond to the pins that are coming out of the premium wiring harness that comes from Haltech. And so it's very easy to configure these, and it's very easy to see which is what and where it's all going, all of those different things. Now, as we take a look at the ignition system here, you can see one of the coolest parts is the safety features that come with having an ECU. One of those is things like disabling the ignition power when the engine is stopped. So now when the engine is not running, that ignition power is not going to be supplied to this high current output. And you can do other things like that within the vehicle functions and electrical setups, all sorts of really cool things you can dive into. Safety features, if your car leans out, if you have an oil pressure connection to it, you can have the engine cut off if you have oil pressure loss. Very, very cool things that'll help protect your engine and keep it from getting damaged, which is, always a really great thing. One thing I did on my car that I'd like to mention is that I did run a separate circuit for the fuel pump so it can all be controlled directly through the ECU. This lets me control the prime time. This can control all sorts of really, really cool things. But in my case, I just have it set up to prime for 15 seconds, and then the pump will turn itself off after 15 seconds. If the car is not started up, if you spin the engine over though, the pump comes right back on. We could spend hours and hours going through these configurations, but for right now, this is just where I wanted to do a little top level coverage of this map. And again, this is available in the links in my description. And please, please read the disclaimers on that site before downloading this and using it, because it is not a plug-and-play setup. It does require configuration and setup for your car. All right, and so with that, that is going to cover, I think, at a top level, everything that you need to know about this setup that you can apply to whatever setup you're gonna be running on your car. Now, I could spend hours on this. We could go into every minute little detail. I think actually it would be a really good chance to do a live stream. Maybe I'll do that soon. But I really don't want to get too focused on the little details here, because at a high level, there's only a few things you need in order to get fuel injection working properly. And to recap, what that is obviously a fuel injected throttle body. I hope that you guys decide that you want to use ours. It's a really awesome unit. It's really well made, and it's going to get you a running vehicle very well, as long as you get that fuel mapping correct. But you'll need that fuel injected throttle body. You'll need injectors. You'll need a fuel pressure regulator for high pressure setups, and you'll need a fuel pump that can handle those high pressures and high flows, as well as a fuel tank with a return. There are lots of options to do that, but the SPI and the MPI tanks are really easy ways to get that done. You'll need a crank position sensor. You'll need a coolant temperature sensor, and then you will need an ignition coil to go with all of this setup. And then all that's really left after that is the ECU itself, which is something that you guys can choose depending on whatever setup and budget you have. With those top level items, you're gonna be able to get your car running and get it to a dyno where you can get it mapped and running really, really nicely. And hopefully within the next couple weeks, maybe a little bit longer, I will have a full map that you can use as at least a starting point for your dyno or your tuning shop to help you get the final way there. Now, obviously, my map is going to be tailored for a boosted setup. So it is not going to be a direct map that is going to apply to every Mini. And in reality, there is no map that is going to apply to every single Mini on the road. There is just too much variance in this engine. It's not like a Golf GTI where, they can sell one map that rules them all. I'm gonna get a stage 1 or a stage 2 map. Doesn't really work like that with these cars. They require a little bit more finesse and a little bit more time on the dyno. So with all of that, I'm gonna cap this episode off here. If you guys have any questions whatsoever, I am available in the comment section below, and I will be happy to answer those for you guys. And make sure to stay tuned, because the next episode, we will likely be getting this much closer to a finished tune. All the refining bits will be done. I have to still add a blow-off valve. I've got to get things configured in a way that's going to look really nice. But we are so close, and I am extremely excited to share this with you guys. So thank you so much for tuning in, and until I see you guys on the next one, you know the drill. Enjoy those minis, and motor on.